Hi, this is Thomas. Welcome back. Our topic is trigonometric identities. This is example 6. Our requirements read: A. Express sine x minus root 3 cosine x in the form r sine quantity x minus alpha, where r is greater than 0, 0 is less than alpha is less than pi over 2, and B. Hence, sketch the graph of y equals sine x minus root 3 cosine x. Notice that in this scenario we're given a sine function and a cosine function, and the procedure in these scenarios is to apply either a sine or a cosine compound angle formula to combine the two functions into one. So step 1, identify scenario, equation, or identity. Looking at requirement B, we see that we are dealing with sort of an equation. In this case, we're actually dealing with a function, but the procedure is equation-like. Given a particular x input, this function would result in an equation that would produce a specific y output. Step 2, identify relevant trigonometric identity. In this scenario, we're given the identity of sine A minus B. Compound angle formula using sine and subtraction. You won't always be given the particular identity to use. Sometimes it requires inspection, maybe trial and error. In this case, we know we're working with sine A minus B, which is an identity with sine A cosine B minus cosine A sine B. Now, before moving to step 3, I want to make some adjustments to my trigonometric identity. Notice in the requirements that we have a coefficient or a multiple of r for sine of x minus alpha. So we'll show that r, and we'll replace the a and b with x and alpha. This is going to be identity with also a multiple of r on the right side of the identity, multiplying by sine what was a is now x, and cosine what was b is now alpha, minus r cosine a will become cosine x, sine b will become sine alpha. Step 3, substitute. We are going to change the left side of the identity to the left side of what will become our equation. And that is the given expression, sine x minus root 3 cosine x. Our requirement is to give that expression in the form r times sine x minus alpha. What's on the right side of the identity in step 2 is going to become the right side of our equation in step 3, r sine x cosine alpha minus r cosine x sine alpha. Before we move to step 4, I want to do some color coding to help clarify the process of simplification. We can match on the left side of the equation the sine term with the sine term on the right side of the equation. And in similar fashion, we'll match the cosine terms on both the left and right side of the equation. And now step 4, simplify to solutions. And let's continue with our color coding. We know that sine x is equal to the sine x term on the right side of the equation, which is r sine x cosine theta. Simplifying, if we divide both sides by sine x, we end up with 1 equals r cosine alpha. And similarly, we know that negative root 3 cosine x equals negative r cosine x sine alpha. Dividing both sides by cosine x, we'll also divide by negative 1 on each side. We'll end up with root 3 equals r sine alpha. Now before continuing, let's be clear. Why do we know these two equations that are in blue and in red? We know on each side of the equation there is a sign term. Sign x is in one term on the left side of the equation, one term in the right side of the equation. Those two have to be equal because there are no other terms in the equation with sign x. Similarly, on the left side of the equation, there's one term with a cosine x. On the right side of the equation, there's one term with cosine x. And those two components of the equation must equate. Now continuing with our simplification. We have two equations and two variables, so we'll proceed with the simultaneous equations process. We're going to divide r sine alpha equals root 3 by r cosine alpha equals 1. The r's will cancel. Sine alpha divided by cosine alpha is tangent alpha. And root 3 divided by 1 is root 3. And now to solve for alpha. Tangent inverse of root 3 equals alpha. And you might know from your unit circle angles that the angle whose tangent is root 3 is pi over 3. Note that we're in line with the restriction given in the requirement. 0 is less than alpha is less than pi over 2. The reason for this restriction is because there are an infinite number of angles with the tangent value of root 3. This requirement guides us to the one that we're looking for. And now to solve for r, we can take either our blue or our red equation. We'll take the blue. 1 equals r cosine pi over 3. And again, from your unit circle angle knowledge, you might know that the cosine of angle pi over 3 is 1/2. So 1 equals r times 1/2. Then dividing both sides by 1/2, we have r equals 2. And again, referring to our requirements, we're required to have an r value greater than 0, which is our case, r equals 2. A calculation of an r value less than 0 would be an indication that we're using the wrong angle. So we've solved for alpha, and we've solved for r, and we can now complete requirement A. Sine x minus root 3 cosine x equals r is 2, sine x minus alpha, alpha is pi over 3, sine x minus root 3 cosine x equals 2 times sine x minus pi over 3. This completes requirement A, and in the next video we'll work through requirement B.